Hello everyone, this is John Jung. Today I will explain I2NSF, NSF facing interface Yang data model. This figure shows I2NSF framework architecture. Today we focus on NSF face interface between security controller and NSFs. I2NSF NSF face interface Yang data model is based on this ITF Internet Draft. Introduction to NSF face interface, it is called the NFI Yang data model. Basically, this NSF facing interface document defines a Yang data model for configuring security policy rules on network security functions NSF in the interface to network security functions I2NSF framework. The Yang data model in this document is for the NSF facing interface between a security controller and NSFs in the I2NSF framework. The Yang data model in this document focuses on security policy configuration for the NSFs discussed in I2NSF capability Yang data model. We have two NSFs. One is generic NSF, the other one is advanced NSF. Generic NSF operates on packet header for layer 2, layer 3, and layer 4. On the other hand, the advanced NSF includes intrusion prevention system called IPS, URL filtering, anti-DDoS, antivirus, and voice over IP, VoIP, and voice over cellular network, VoCN filter. Okay, let's start from I2NSF security policy. So this is right hand side we have I2NSF NSF facing interface Yang tree. So I2NSF security policy includes many fields: name, language, priority usage, resolution strategy, default action, rules, and the rule group. So we can make a group having multiple rules. Each rules also has multiple fields: name, description, priority, and enable long connections. Okay, and the event condition action ECA policy rule. So name is security policy name. Language is the description language. Usually we using US English. Priority case we have two things. One is priority by order and priority number. Priority by order case, the sequence of rules to be executed follows the input order by user. On the other hand, the priority by number case, the higher value is a higher priority. And resolution strategy. So if there is a conflict that occur between the actions of the same or different policy rules that are matched and contained in a particular NSF case, we have several resolution strategy. First, matching rule, FMR, last matching rule, LMR, prioritized matching rule, PMR with errors, PMRE, and prioritized matching rule with no errors, PMRN. So we can use one of them. And default action is used to execute I2NSF policy rule when no rule matches a packet. Default action can be pass, drop, reject, late limit, or mirror actions. Also, we can support vendor action features. The rules include rule name, rule description, rule priority, rule enable long connection, event condition action. Okay, we have this comma here. Okay, pen here. Okay, so we have separate. Next, so event, condition, action. Okay, so we can see one step at a time. Security policy, event clause. This is on any important occurrence at a specific time of a change in the system being managed and or in the environment of the system being managed. Okay, so we have two kinds of events object: system event, system alarm. System event is a warning about any changes of configuration, any access violation, the information of sessions and traffic flows. On the other hand, the system alarm is defined as a warning related to service degradation in the system hardware like CPU overloading, memory full, something like that. Okay, this is Yang module for event. Here, event clause. Secondly, the policy condition clause. So once event is satisfied, we evaluate the condition and clause. Condition clause is defined as a set of attributes, features, and values are to be compared with a set of non-attribute features and the values in order to determine whether the set of actions in that imperative I2NSF policy rule can be executed or not. So condition clause works with and logic. All fields set in the condition must match the packet or flow for condition to be evaluated as true. So we have three kinds of condition: generic network functions, advanced network functions, or context. Okay, so generic network security functions case usually the packet header layer 3 or layer 4 and ICMP. Okay, so this is based on access control. Okay, so Yang data model for network access control and NACL ACL list. So it is called ACL. And advanced network security function like URL category condition, voice, DDoS payload condition, and a condition clause of context, okay, is defined as application condition, target condition, users condition, and geography condition. This is part of advanced network security functions. Okay, let's take a look. So security policy condition clause layer 2. Okay, layer 2 is data link layer. So destination MAC address, destination MAC address mask, and source MAC address, source MAC address mask, and the Ethernet type 2 bytes. Okay, so this one is used the upper layer like network layer. Also, it can be used the virtual LAN. And then condition clause layer 3. Okay, let's take a look. So network layer, IP version 4, IP version 6. Okay. DSCP and ECN, those are part of IP header TOS. Okay. Type of class TOC, right? So for quality of service, DSCP, this one stands for differentiated services code point. Okay, for DSCP, And the ECN is explicit congestion notification for congestion control. Okay, so you can refer HRFC. And the length is IP version 4 case. This field is a total length. Okay, so the length of datagram, including internet header, IP header, and the data. And the IP version 6 case, this field is payload length. The length of IP version 6 payload. The length of the packet following the IP version 6 header in octets. Octets means bytes. So this is shows yang tree for IP version 4, IP version 6 layer 3. And TTL, time to live lifetime, the protocol, upper layer protocol. IP version 6 case, the next header is used, indicate the next, okay, protocol payload packet, and destination address and the source address. Okay, so IP version 4 case 32-bit address, IP version 6 case 128-bit, 4 times okay bit length. So version 4 case we are using dot notation, and version 6 case we using colon notation. Okay, and also non-shared IP version 6 and IP header case. Internet header length IHL is for IP version 4. Okay, this is the length of internet IP header in terms of 32-bit words. And the flags, this indicate IP version 4 header flags. And the offset, this is the fragment offset in IP version 6 header for fragmentation. And identification case, this is indicate fragmented datagram. And the flow label is for IP version 6. This is IP version 6 flow label, 20-bit flow label used by source to label sequences of packets to be treated as a single flow in the network. Okay. And then, so let's move on. Layer 4 case, we have TCP, UDP, SCTP, DCCP, 4 kinds of transporter layers are supported. Also, ICMP version 6, 4 and version 6 are included as a choice for layer 4 as a header fields because they are above layer 3 network layer. So TCP case, source port number and destination port number included, and the sequence number for the sync is the first 318 case, right? So in that case, first the data octet start the initial sequence number plus 1. Acknowledgement number is used to indicate the next sequence number the sender of this segment is expecting to receive, okay, next time. And data offset, this is indicate where the data begins. And the reserved is reserved for future uses, but this is set to 0. A non-zero field means the packet should be filled out, and flags. Okay, this is used control for layer 4, such as conjunction window, reduced ECN, explicit conjunction notification, echo, urgent point, acknowledgement, push function, reset, synchronization sequence number, last package pin to finish the session of TCP. TCP connection terminated means no more data from sender. And TCP header include the window side. This one is receivers, okay, available window size for flow control. And the urgent pointer means the first urgent data byte starting point of urgent data. Options, okay. TCP header has many options can be supported, okay. So the options have up to 3 fields: option kind, option length, option data, okay. And the UDP, okay. So UDP case, UDP port number, UDP destination number for port number, and the length in bytes of UDP header and UDP data, okay. And next move on, SCTP, third transport layer protocol. SCTP stands for Stream Control Transmission Protocol. This is a mix of TCP and UDP. It includes the source port number, destination port number. Also, it supports the chunk, so chunk type, which identifies the type of information contained in chunk value field, and chunk length. This is size of chunk length. And the last transport layer protocol is DCCP. DCCP stands for Diagram Congestion Control Protocol. This is enhanced version for UDP, provide congestion control. This is includes the source port number, destination port number like TCP, UDP, SCTP. And DCCP header includes a service code, type, data offset. So DCCP service code, the application level service to which the client application is trying to connect, and type is 4-bit DCCP type. So we have like this DCCP request, response, data egg, and data offset, the offset from the start of application data. Okay, the starting point of application data area. And the ICMP also treated as a layer 4, so version 4, version 6. Type code is used, right? And the rest of header is used. Okay, so the rest of the header field, this is the content vary based on ICMP type and code. Okay. Okay, and then we have advanced NSF. Okay, advanced network security function. So URL filtering case, URL category condition is used. Okay, so predefined, user-defined URL used, specify URL filtering, and the voice over IP or voice over cellular network case, voice condition is used. Okay, so source voice ID, destination voice ID, user agent information is used to filter malicious voice over IP or voice over cellular network packet. And DDoS attack mitigation case, DDoS condition is used. So packet rate, flow rate, byte rate is used to over those threshold treated as a DDoS attack. So alert packet rate case, the alert rate flood detection, packets per second, PPS. So alert flow rate case, TCP connections per second, and byte rate case, bytes per second, BPS. Okay. Antivirus condition. Okay, so antivirus case, profile exception files. Profile specifies security profile for antivirus. Okay, so this profile for improving security. It is used to scan viruses. Exception file is type or name of file to be excluded by the antivirus, bypassing antivirus. Okay. So absolute passes are file name or passes to be excluded. Also, it is supported like relative one means global. Global means pass names matching a pattern like star.txt means any kind of txt file can be handled by antivirus or excluded, okay, the antivirus service. Payload condition is this is for deep packet inspection. So the content specify the payload. This should be liter T, okay. Okay, so this is a liter T, okay. Okay. So payload condition is used for the packet inspection service. Okay, so right hand side it shows your category voice DDoS antivirus. So payload. Okay, so we have a context condition, time condition. So we can specify the interval for specific network security service. So start date and end date, okay, time can be specified. So start date time means start date and time, okay, and the end date time is end date and time. So we will see example later on. And frequency. So frequency specifies how frequently the rule should be enforced. So at once, only once rule immediately enforced during this start date time through the end date time policy will be um, enforced. And daily, weekly, monthly, yearly, we can specify a frequency. And the period is specify some repetition time for security policy. We can using the frequency value. So start time and date months. So and start time and end time is for the day for policy to be enforced, and the day is the weekly based. The okay repetition date is monthly based repetition. Month is yearly based repetition provided, and the context condition clause includes application condition like protocol such as HTTP, HTTPS, and device type. You can handle the type of device, okay, like router, switch, PC, iOS, Android. User case we have two, individual user and a group of users. Okay, so using the user ID, group ID, specify user or group individually. Okay, and the geographic location condition is used to specify geographic physical location such as country, province, and city. Also, logical network condition, network location can be specified, such as IP address, network section, and network domain. So source destination specify geographic location of a source packet and geographic location of destination packet. Okay, so right hand side we have context. Okay, time, application, users, geographic location. So next, we'll see ECA, event condition action. So action clause, okay? So action is used to control and monitor aspects of flow-based NSFs when the policy rule, event, and condition clauses are certified, okay? So event condition clause is certified, we can perform corresponding action. So action has ingress action, egress action, log action, three things, okay? So the packet action, flow action, advanced action case per these kinds of three the types. So we can have a packet action is for individual packet, and flow is for session or track flow like a TCP session, HTTP as a session. Okay. Advanced action is for advanced security service such as URL filtering, DDoS attack or DDoS attack mitigator, VoIP, or a voice over serial network filter. So we can apply. So advanced action is usually provided using service function chaining, SFC. Okay. So the action clause can be executed according to specific vendor action features. So we have ingress, egress, log action. So ingress implies the action for traffic entering the boundary of a network. Okay. So pass, drop, eject, light limit, the meter. The pass is just allows a traffic pass through NSF. Drop case just a drop matching the rule. Silent drop. Okay. Reject case different from the drop case denies drop packet and also send a response back to source. So like ICMP version 4, version 6 case, destination unreachable case error a message delivered even though original packet is dropped by the router or the host. Okay, and late limit is limit the number of packets or flow that can go through NSF by dropping packets or flow randomly or systematically. So drop mechanism, silent drop, unreachable drop, is up to the implementation, local policy. The middle case copy packet. So original packet is allowed to go through the NSF. The other copy sent to the monitoring entity, okay, for analysis. And the egress is the action for traffic exiting an entry over a network boundary. So the basic actions, those pass, drop, reject, late limit, meter, are included by this one. In addition to them, invoke, signaling, tunnel, encapsulation, forwarding, transformation are supported. Invoke signaling is to convey information of the event triggering this action to monitoring entity. Tunnel encapsulation case just tunneling by encapsulating the packet and then tunnel to the destination. Okay, and forwarding cases just relay the packet from one network segment to next hop in the network. Transformation case transform a packet by modifying the header packet format like HTTP to COAP. So HTTP is for the web traffic. COAP is a constrained application protocol for IoT device. Okay, so this HTTP packet is transformed lightweight HTTP version COAP packet. So this transformation is used. Okay, and log action is used traffic logging. So rule log, session log are supported. So rule log is a log the policy rule triggered by packet overflow. Session log is triggered, okay, policy rule. Session is a connection like traffic flow over data plane, including source and destination information, and like IP addresses and portal numbers. Okay. So last one is security policy. You can see we saw okay. So event condition action so far. Rule group. So rule group is used to group okay, rules into a rule group, like group of rules. So we can enable this field, set enable field. Okay, so enable field. So description can be used to describe the region of enabling, disabling rule group for future references. So multiple rules can be grouped by one group name. Okay. So let's take a look examples of NSF facing interface configuration. So the first example is a time-based firewall version 4. So basically, this one is the source, this subnet traffic generated toward the URL filtering. So URL filtering case, some SNS website, we going to next, okay, service, next slide include URL filtering XML. So during this starting and ending date and time, and then we repeat this one period. Okay, so the work time, the weekdays, we can perform it URL filtering. So this one is I explained, and then URL filter, right? So in that case, Facebook and Instagram traffic it dropped. Okay, so using service function chaining, we can provide time-based firewall service. Okay, and the next one is DDoS mitigator. So alert flow rate per second. This kind of number of flows is detected by NSF. This DDoS attack mitigator NSF, okay, delete, okay, randomly drop or full drop according to the implementation. Okay. So this XML code shows DDoS attack mitigator, right? So alert flow rate, okay, this number, okay, so 100,000 per second, okay, is set up for DDoS attack mitigation. Conclusion, in this class, we learned the I2NSF NSF face interface, Yang data model. Okay, this is for data model for low-level security policy. So previously, CFI, okay, consumer facing, okay, interface, okay, it is called CFI, right? CFI, Yang data model we learned, right? So this is a high-level security policy. So using security policy translator, security policy translator. Okay, so this is used to translate high-level policy, okay, policy, security policy into low-level security policy. And then NFI Yang data model uses ECA policy model, event condition action, to activate the rule. And then also NFI Yang data model provides access control list ACL to filter packet-based RFC, this one, 8519. And NSFI Yang data model also provide the compilation for advanced NSF like URL filter, web filter. It is called web filter. Okay, and voice IP and voice over cellular network, DDoS, distributed denial of service mitigator, and intrusion detection system IDS, and antivirus. In this class, the usage of I2NSF face interface young data model is shown with example like time-based firewall and DDoS attack mitigator. Okay, if you have a question, please let me know. Thank you for your attention.